Good day and thank you for joining us. So if you can recall in our last two videos when we were dealing with analytical geometry, the first video we looked at some revision, and then the second video we looked at proving certain quadrilaterals using our analytical geometry. So in today's lesson we're going to be looking at an exam type question, and before we get started I'd like to give a special thank you to South Peninsula High School for allowing us to use their past paper. This is their November 2017 paper, question 3 for analytical geometry. Cool, so let's just get straight into it. It says here in the diagram, C is a point on the y-axis such that A, 0 and 4, B, 4 and minus 4, C, and D, minus 4 and 2, are the vertices of the parallelogram ABCD. K is the point 0 and minus 2 and a quarter, and L is a point on AB such that KL is parallel to CB. Cool, so all of this information is going to be very important to us. So if ever we might get stuck with a question, we always need to refer to this information at the top, and maybe it helps us. A lot of our information is found in the top over here. It helps us answer our questions down over here. Cool, so let's have a look at question 3. So we're doing 3.1 first. And so as we can see, 3.1 asks us to determine the length of the diagonal DB. Cool, so DB, that's coming from the top of here all the way down to B over there. Cool. So we're literally just going to do the distance formula for that diagonal DB. So put in DB is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Cool, that is our distance formula. By now we should have most of our formulas memorized because of repeating them constantly and constantly doing them over and over again. So we're going to move on. We're going to do our substitution now. So D I'll use as 1 and B I'll use as 2. And remember, when I say I'll use D as 1 and B as 2, it means that I'm getting x1 and y1 from D and x2 and y2 from B. Cool. So let's go ahead now. It's going to be it's going to be positive 4. That's the x2 that's coming from B, right? And then it's going to be minus negative 4, which is coming from D. Cool, so it's going to be plus by substituting in the y values now. So it's minus 4 minus 2, that's squared. Okay, now we can go 4. So this is a negative times a negative, that gives me a positive. So this is actually 4 plus 4 squared. Sorry, I forgot to include the square there. It's plus minus 2 minus 6 gives me minus 4 minus 2 gives me minus 6. That will be squared. And so on the left hand side we have 4 plus 4, which gives me 8. And that 8 squared will give me 64. Plus this is minus 6 squared, which will give me, obviously negative squared gives me a positive, so it's 36. That will give me the square root of 100, and so the length of DB is 10 units. So next up, what we can do is we can have a look at 3.2. It says determine the coordinates of M at the midpoint of DB. Cool. So we just worked out the length of DB. Now we need to find out what the midpoint is. Cool. So we'll just do the basic midpoint formula. So it's midpoint of DB is equal to, so we put in our formula now, it's x1 plus x2 over 2, y1 plus y2 over 2. So what I want you to do is just pause the video here, maybe try and give yourself a chance going through this. I've given you the formula. All you need to do now is substitute in and then find the answer. So give it a pause now, and straight after you press continue, I will be explaining the example. So now to have a look at substitution, we're going to substitute in. Okay, so I'll use D as 1 and B as 2 once again. So it's going to go minus 4 plus 4, that's over 2, and this is going to be 2 minus 4, right? Because obviously I would substitute in a minus 4 after the plus sign, but it changed the plus sign to a minus sign. Okay, that will be 2 over there, And so we know minus 4 plus 4 will give me a 0, so my left side I know equals 0. And then over here I have 2 minus 4, which gives me minus 2 over 2. And so now our midpoint of DB is 0 and negative 1. And that is finding the midpoint of the line DB. So now just quickly before we move on, you can see I've just kept all of our notes here at the top of the things we found. We found that DB is equal to 10 units, and we found that the midpoint of DB is 0 and negative 1. So now we'll move on to question 3.3. It says determine the gradient of the line AD. Okay, cool. So we have the line AD over here, and so all we need to do is find the gradient of that line. So we know the gradient formula, so we find a gradient of AD is equal to y2 minus y1 over x2 minus x1. So all we can do now is substitute in. I'll use a as 1 and d as 2. So our y2 in this case is 2 minus our y1, which is 4, over our x2, which is minus 4, and minus by our x1, which is 0. And so what we end up getting here is 2 minus 4, which gives me minus 2, and minus 4 minus 0, which gives me minus 4. So because we have a negative at the top and negative at the bottom, clearly we know that when a negative is divided by a negative, we get a positive. So this will actually equal a positive half once we simplify that fraction. And so that is the gradient of AD. You can also just quickly record that here at the top. So we found the gradient of AD is a half. And we'll see if that proves helpful later on. Cool, so now we can move on to 3.4. Sorry, just selected the wrong color. So 3.4. It says prove that AD is perpendicular to AB. So we've already found the gradient of AD. So we need to prove now that AD is perpendicular to AB. AB is our line over here, right? And we can see they're attached over there. So how are we going to prove that they are perpendicular to each other? We know that perpendicular lines, when we times the gradients together, that gives us negative 1. So basically what we're going for here is the gradient of AD times the gradient of AB needs to equal to negative 1. So we're going to try and prove this formula. So we already have the gradient of AD. What we need to find now is the gradient of AB. Cool? So let's go ahead and do that. So we're going to say gradient of AB is equal to y2 minus y1. Remember, it's always important to write out a formula, and that's over x2 minus x1. Now we'll substitute in. We're going to use a as 1 and b as 2. So our y2 in this case is minus 4 minus our y1, which is 4. And then we're going to go x2, which is 4, minus our x1, which is 0. And so minus 4 will give me a minus 8. And then 4 minus 0 gives me 4. And so what this answer works out to is negative 2. Right? Because 8 divided by 4 will give me 2. So that's the gradient for AB. So now what we have to do is just rewrite this formula, but with the values substituted in. So remember, our gradient of AD was a half. So let's just write this over again. So it's going to be a half times our new gradient that we found now, which was minus 2. So if I times, so remember we want the equal to negative 1, right? If I times a half by negative 2, that will give me an answer of negative 1. So I can say therefore it is equal to. Remember, I said in the past, if it's not, we put a line through it, but they're actually asking us to prove that it's perpendicular, so we already knew it's going to be perpendicular in this case, right? So just like that, we've proven that it was perpendicular. We had the gradient for AD, we just had to find the gradient of AB. Once we get that, we times them together, and if they're equal to negative 1, we know that we are correct and have proven that they are perpendicular. And let's just also look at 3.5 quickly. We can fit it in here actually. So 3.5 says, what type of parallelogram is ABCD? Explain your answer. Cool. We can deduce that this is a rectangle. And why is that? Because if we go to parallelograms, we know that a parallelogram with a 90-degree angle, remember, perpendicular meets at 90 degrees. So a parallelogram with a 90-degree angle is a rectangle. So we can just say a rectangle. It's a parallelogram with a 90-degree angle. Cool. And just like that, we've identified what type of parallelogram it is, and we have explained our answer. That's all they need from us there. So going over to the next page, we can see we have 3.6, 3.7, and 3.8. So let's go ahead and do 3.6 right now. So it says, determine the equation of the line KL in the form y is equal to mx plus c. So it's right there, y is equal to mx plus c. So we know which form we're using. So we try and find the equation of line KL. So let's have a look at line KL quickly. So line KL, we can see over here, you can see it starts at the y-axis and it moves all the way to L. Cool. One thing that's very important for us to note here is that we can see that KL they let us know that KL is parallel to BC, right, or CB. So we know KL is parallel to CB, but if you look closer at the diagram here, and because we know it is a rectangle, we know that CB is also parallel to DA or AD. Why? Because we know that a parallelogram has two pairs of parallel sides, and AD and BC are one of those parallel sides. So with that being the case, and AD would then be parallel to KL, we know that AD and KL have the same gradient. So let's look at AD quickly. We found the gradient of AD, which was a half, right? So wouldn't that mean that the gradient of KL is the same then? Definitely is. So what we can go ahead and say is that M, so the gradient of KL, is equal to the gradient of AD, which is equal to a half. Cool. And we can say in brackets there or anywhere close by, just saying that AD is parallel to KL. So then now we got that information, right? So if we rewrite our equation now, it's y is equal to half x plus c. And now obviously our c value, we know that is the y-intercept of the line. And if we look here, remember the line starts on the y-axis. And that is the point K, right? And they actually give us the coordinates for point K. Obviously, it's 0 and minus 2 1/4 because it's on the y-axis. So from this, we can clearly see that we are given the y-intercept of the line KL. And so just like that, we can give them the final equation, which is y is equal to a half x minus 2 1/4. So all we did there is substitute in those values. We knew that the gradient was the same as line AD because the lines are parallel. And obviously we saw given to us that C is minus 2 1/4. So now let's go ahead and look at our next question, which will be 3.7. So 3.7 says determine the coordinates of C. So we're trying to find the coordinates of C down here. And so this is one of those where we can solve by inspection. And the way we do that is we can have a look, because we know that CB is parallel to AD, or BC is parallel to AD, whichever order you want to say it. We can sort of look at the behavior of the coordinates between these two lines. So if we see at the top here, the highest point of the line AD, it's 0 and 4. And the lowest point is 4. And here at the highest point of the line BC, it is 4 and minus 4, right? So we're looking at the highest points, we see that. Now let's look how they move from their highest point to their lowest point, right? So they would move in the exact same way because they have the same length, because it's a rectangle, and obviously they are the same gradient because it's a parallelogram, right? So this is 0 and 4, we see how it moves down, and it moves to minus 4, so 4 units to the left, and it moves to positive 2, so 2 units down. So we're moving 4 units to the left and 2 units down. Cool. So if we do that, so we're trying to point C now, obviously we're moving from point B. So if we come here on the right hand side, we have 4 and minus 4, right? So remember, A moved to D 4 units to the left. So if I'm moving 4 units to the left, remember that's minus, right? And it's affecting the x value, so it's minus 4. And so 4 minus 4 will give me 0, right? And also we can see that that's definitely the case because C is on the y-axis where x is equal to 0. And then what happens to the y value? It decreases by 2. And so what's happening? We're just going to minus 2 from minus 4. So minus 4 minus 2 will give me minus 6. And just like that, we found the coordinates of C. Now let's have a look at our last question now, which is 3.8. So 3.8, it says, if B, A, and F are collinear, determine the value of K. So we're trying to find the value of K, and they've told us that B, A, and F are collinear. So obviously F isn't in the diagram over here. They're just letting us know that F is a point such that it lies on the same line as AB. That's basically what collinear means. They're on the same line. So if they're on the same line, it means that they have the same gradient. So let's just take what they told us F is 2 and K. Cool? So we're trying to find out what the value of K is. And they've told us on the same line, which means it's the same gradient. And so what we can do is, we know the gradient of the line AB, we worked it up before, right? It was minus 2. So what we can do is substitute F into a gradient formula with either the point A or B, and have K as the only unknown in that equation, and then solve for K. And I'm going to show you how that looks right now. We'll use the point A. It doesn't matter, you can use A or B, I'll use A in this case. So we can do the gradient formula, so that's the gradient is equal to y2 minus y1 over x2 minus x1. So we already have the gradient in this case, which is minus 2. And so we can substitute our values. We can use, let's say, A as 1 and F as 2. Cool, so we have y2, which is K, minus y1, which is 4. And that's over x2, which is 2, and x1, which is 0. And as you can see, K is the only unknown in our equation now. And so we can just go ahead and solve for K. So obviously we know 2 minus 0 is going to be 2. So to get rid of that 2 at the bottom of the fraction, we can just times by 2 on this side. What you do to the one side, you do to the other side as well. And so what happens is this becomes minus 4 is equal to K minus 4. And now all we need to do to get K by itself is take negative 4 over. And so negative 4 comes over, it becomes positive 4. And then, so let's have a look at 3.8. 3.8 asks us to, and so it says, if B, A, and F are collinear, determine the value of K. So we're just going to take the value of F here quickly. It's minus 2 and K. And so basically they're saying if B, A, and F are collinear. So collinear means that they lie on the same line. Obviously, F isn't given to us, right? So we just have to place it in our heads basically into the scenario. And so what collinear means, they're on the same line, which means that they have the same gradient, right? So what we can do is use the gradient of this line AB, which we already found, which is minus 2 over here, correct? So what we do is we can use that gradient, and we can just plug F into a gradient equation with either A or B, because obviously the gradient is equal, so that would make K the only unknown in that equation. I'm going to show you how that works right now. So we're going to use the gradient formula, which is M is equal to y2 minus y1 over x2 minus x1. And then what we'll do is we'll substitute in, obviously we know our gradient for this line is minus 2. And so I'm going to use the point A. You can use either the point A or B, it doesn't matter, you'll get the same answer. And so what happens is now I'll substitute in and I'll use A as 1 and F as 2. It doesn't matter with that either, you can use it either way. I'll just use A as 1 and F as 2. And so if I'm going to substitute in now, it's going to be F being y1, y2 and x2. So if we substitute that in, y2 is going to be K minus our y1, which is 4, that's obviously from A over there, all over x2, which is minus 2, right, all the way up from F, and that's minus by 0. So what's going to happen now is we are going to solve for k, as it is the only unknown in our equation. Obviously we know minus 2 minus 0 will give me minus 2. So to get rid of it, I need to times by minus 2, right? Because it's part of a fraction. To get rid of that, I times. So what I do to the one side, I have to do the other side, and so I get positive 4. Sorry, it's positive 4. Just remember, it's a minus times a minus. So this is positive 4 is equal to k minus 4, right? And so all that we have to do now is take 4 over to get k by itself. And so to take me to there, 4k is equal to, so obviously 4 comes over, becomes positive 4, so 4 plus 4 gives me 8. And just like that, we've solved for k using the collinear advice that they had given us. And just like that, guys, we've done our past paper question. Thank you so much for joining me. I hope that this past paper question has helped you just how to understand and apply the work in your exams when you write. All that is left for you to do now is to have more practice with more past papers, and I can guarantee you will see improvement in your results. Thank you so much, guys, and I hope you have a good one.